I'm Lavindra Silva. I'm a research professor in the Cambridge University Engineering Department, and I'm also a program director for the Digital Roads of the Future initiative. And my responsibilities generally involve technical leadership over the various aspects of the program to make sure that they link up and deliver impact. The DRF initiative is a combination of 3 separate programs: Digital Roads, FutureRoads, and the Roads Research Alliance. And the latter is a consortium of about 25 companies which have come together to essentially steer the direction of the initiative. FutureRoads, on the other hand, is a similar consortium of about 25 companies which have set challenges that are industrially relevant to the road sector. And these challenges are met by proposals from researchers from around the world. And the winning proposals essentially get funded by the European Council through a Marie Curie Researchers Program.
I'm Dr. Jinying. I'm a Marie Curie Fellow working on the FutureRoads Fellowship Program. I work under the theme of sustainability with Dr. Kristen McCaskill. My research is to develop a standardized carbon data collection methodology that can be used by all value chain stakeholders along the whole life of highway assets by using data science and advanced digital technologies. Based on that, this research will also develop an intelligent carbon management system. So this is fundamental research driven by the practical problems facing by the infrastructure sector, and it will directly support the net zero targets. One of the significant sustainability challenges is the climate change brought by greenhouse gas emissions, and the infrastructure sector contributes a big part of it. And to reach net zero, we need to remove as much as we emit. So we need to get the numbers right. That's actually a mathematical problem. To do the carbon measurement accurately, so we will get the accurate numbers, and that will help us with data-informed insights about the hotspots of carbon emission and also how to reduce carbon effectively. Current carbon data management is based on manual data collection and many rough assumptions. And different organizations are using different methods or models to collect the data in the practices. And the data they collected in this way cannot be trusted or shared. So this poses a big problem for us to get the net zero target, and a standardized carbon data model that I'm developing in this project can help to fundamentally solve these problems by defining a more accurate, automatic, timely, and trustworthy set of data collection approaches that can be used by different stakeholders along the whole life of the highway assets. The advanced technologies and techniques I'm exploring, including the open bin, digital twin, Internet of Things, blockchain, and other enterprise digital systems like the ERP or the procurement systems to enhance the data availability, operability, and reliability. Also, I'm developing a carbon data ontology to enhance the data interoperability. Developing interoperable protocols can help different stakeholders follow the same set of data formats and data management procedures. It's like developing a common language everybody can understand. So this is very important for a fragmented industry like the infrastructure sector and to a complicated topic like carbon management. And it can then join their efforts in a more efficient way to understand carbon emissions and reduce carbon. Developing interoperable protocols can help different stakeholders follow the same set of data formats and data management procedures. So it's like developing a common language everybody can understand. This is very important for a fragmented industry with a pronounced supply chain like the infrastructure companies, and for a complicated topic like the carbon management. So it can then join the efforts in a more efficient way to understand carbon emission and reduce carbon emissions. Future technologies are changing very fast, and by using international standards and open formats, we can ensure that the intelligent carbon management system will be adaptable to new technologies. And integrating future technologies can help us increase the level of detail, level of automation in the data collection. And with big data analytics and AI, we can better analyze data and support decision-making of carbon management in a more efficient and optimized way. I hope my project can advance the carbon management in a standardized, automated, and trustworthy way. With the standardized data collection methodology and the intelligent carbon management system, the industry can better collect data and make informed decisions to reduce carbon emissions. And the outcome will help developers and other stakeholders to achieve their net zero targets in an easier and more confident way. And the policymakers can also promote the standardized carbon data collection in the sector of infrastructure and other sectors as well. My key message is that standardization is not just about carbon data, it's about any other types of data and other applications and processes. With such a fragmented industry, we need to have this standardization so that we can follow things, we can move the automation and digitalization of the future road development. And it needs joint efforts from the whole supply chain to work together to create these standardized processes and procedures that will save us a lot of efforts in tackling the future sustainability challenges in our road development.
My name is Arsen Abdulali. I'm a Marie Curie Fellow. I'm currently working on FutureRoads project, where I'm trying to develop collaborative robots that can seamlessly communicate with people and be a part of the team and help them mediating most of the manual hard work. We have like a lot of problems in the industry 4.0 that we don't have a human component in those things. Like we optimize and develop digital twins, but the human factors are not really included in there. So now we are moving to industry 5.0 that have this component in it. And the key aspect of industry 5.0 is actually interactive digital twins with the human in it. Interactive digital twins enable human to interact with the virtual world. So the human can cooperate with the robot in it. So the human can adjust or do all the manual tasks that they used to do in the physical world, they can do it in the virtual world. In a way, the digital twins can be optimized in the cooperation with the human. So it's a human in the loop of the design of the digital twins. There are a few challenges that we are currently facing. One of the main challenges is that robots currently, they don't really understand human behavior, and they need to have explicit control. We need to tell robot what to do, when to do, and like providing the precise positions and so on. In the human world, we have a bit different way of interaction. We have a common sense. We don't really need to tell each other explicit information, and all the communication is implicit. So we are working towards this direction. Another thing is that there is no good way to interact with the virtual world yet. So we need to make a design of the interfaces to enable human to interact with the virtual world, and we need to design those algorithms that can provide like a good tactile feedback that human is experiencing in the physical world. Construction and maintenance are the fields where we can get the biggest impact. There are a lot of works done manually. People are working in the severe conditions. They work at night, they work in cold. The environment is also unstructured, dynamic, and it's difficult to automate roads. So it is a best scenario when the robot should work in synergy with the human. And it's the place where we cannot really replace the human, but we can assist the human. We actually made a good progress already. And now we have established a framework for the implicit communication between human and robot. We basically reduced the active control time nearly 4 times, which helps human to interact with the multiple robots that we are currently working on. We also work on embedded AI. We currently working on the embedded AI algorithms that helping to learn the contextual model and human behavior, so the robot can understand better human. As well as we are working on the interactive digital twins, where we have also quite a good progress. Now the human can touch and interact with the different materials with the different properties like hyperelasticity, plasticity, and different textures. Hyperelasticity is the material like rubber and other materials that expand and deform to the large extent when we interact with them. Plasticity is the other sort of materials like a clay, like any other compounds that we use usually in our road industry or in the food industry, like a dough or this sort of materials. The key takeaways from the projects are if we want to reach the sustainable goals of the development provided by UN, we really need to move to the industry 5.0, which is like human-centric. To make our industries human-centric, we really need to work on the interactive digital twin, so we can make those digital twins more inclusive. Also, we need to make the communication between human and robots more seamlessly. To do this, we really need to learn human behavior, and we need to make robots understand contextual situation.